Okay, welcome to 3.3 Polynomial Inequalities in two variables. And the objective will be to graph polynomial inequalities in two variables and to graph the solution set of a system of inequalities. Two variables. Well, first of all, the last section, 3.2, we were doing inequalities in one variable, and those were graphs on a number line, only one dimension. All right. Now, in two variables, our graphs will be in the plane. All right. So we're going to get stuff like this now. All right. And let's see. Let's talk about what happens here. So if I have like a line right here, this equation, every point on this line would be y equals, and let's go ahead and practice this. This is mx plus b, so what's the slope right here? Well, if I go from this point to that point right there, it looks like I'm going to rise 1 and run 2, so I have a slope of 1/2. And then what's my y-intercept? It's that 1 right there, plus 1. So this line represents every y such that y equals 1/2 x plus 1. Now, let's talk inequality. So what about everything above that line? Well, what do we have right here then? We don't have y equals 1/2 x plus 1. We have y is, and this stuff is above that line, so y is greater than 1/2 x plus 1. And now, what about the other half of the plane that is below that line? Well, what's that going to be? It's going to be an inequality, and this is going to be y is less than the 1/2 x plus 1. So every equation divides the plane into two parts, everything above it and everything below it. Two variables, and that's all there is to that. Okay, well, let's practice with like a quadratic or something. All right, so y equals x squared minus 2x minus 8. For now, I'm just going to give you this graph right now. Okay, there it is right there. Kind of rough, but that'll work. All right, now, so this parabola represents every y equal to x squared minus 2x minus 8. Now, what about the stuff above that parabola? That would be this area right here. All right, and we're going to write that y is greater than x squared minus 2x minus 8. Okay, and now how do you represent a graph of everything that is less than x squared minus 2x minus 8? Well, all I do is I draw like a rectangle right here to stress the region, and this region right here is everything below y equals x squared minus 2x minus 8. So we're going to write that y is less than x squared minus 2x minus 8. Okay, let's do one of these from scratch here. Okay, so sketch the graph of y is greater than x squared minus 2x minus 8. Isn't that what we just did? Y is great. Yeah, it is right here. But let's do it step by step and do this perfectly now. So if this is a problem on a test or a quiz on your homework, the first thing you're going to want to do is find the roots of your quadratic right here. And to do that, we'll factor it. So y then would have to be greater than, well, what are the two factors of x squared minus 2x minus 8? Well, I'd have an x and an x, and then I need a product of negative 8 and a sum of negative 2, so wouldn't that be a negative 4 and a plus 2? There you go. So I see my two roots right now, so I'm going to break out my coordinate plane, and the factor of x minus 4 would give me a root of 4 right there. And the factor of x plus 2 would give me a root of negative 2, which these are scaled by 2, so that's right there. Now, doesn't the vertex have to be right in between these two roots on the axis? So I already know the axis, okay? I'm going from negative 2 to positive 4, so wouldn't the axis of this quadratic be x equals 1? X equals 1 right there. And if you don't remember that rule, you can just use your old x equals negative b over 2a. Okay, so x equals negative b over 2 times a, which would equal, well, what's the opposite of b? The opposite of negative 2 would be a 2. over 2 times the 1 would be a 2, and there it is, my x equals 1 right there. And now you need the y coordinate of the vertex now. You know the vertex exists on the axis, but where's it at? Well, let's just do direct substitution. So p of 1 equals, and I'd use the factored form right here, 1 minus 4, that's negative 3, and 1 plus 2 is 3. Negative 3 times 3, that's going to be a negative 9. So let's go down to, looks like I scaled the y-axis by 2's 2, negative 4, negative 6, negative 8, so negative 9 would be right down in here. There it is. There's my point, 1, negative 9. Now, I also, little review of graphing quadratics, you see the negative 8? Isn't that my y-intercept? So that'd be right there. Okay, now I need to think too. Y is greater than x squared minus 2x minus 8. So when I draw my parabola through those 4 points right there, I'm going to draw it as a dashed line. Dashed curve, I should say. And there it is right there. Now, sketch the graph of y is greater than x squared minus 2x minus 8. Well, wouldn't that be everything above that dashed parabola, or everything on the inside of the parabola right there? And there's the perfect graph. Y is greater than x squared minus 2x minus 8. Okay, let's just keep going. So let's graph the solution set of the inequalities. Y is less than or equal to 4 minus x squared, and y is greater than x plus 2. So we have a parabola opening downward, and then we have a line with a slope of 1 and a y-intercept of 2. So what I'd do is I'd graph my boundary lines and then shade the region that works for both of these inequalities. So let's do this step by step. Now some of you can already see the boundary line for 4 minus x squared. You're just taking y equals x squared, you're reflecting it in the x-axis or flipping it over and then sliding it 4 units up. But let's make sure we can do this perfect. So if I want to find the roots of this, I'm going to factor it. So y is less than or equal to 4 minus x squared. Well, isn't that the difference of squares? Why, yes, it is. So I'm going to write this in factored form there. And now 4 minus x squared would factor 2 minus x and 2 plus x. All right. So now look at these carefully. My first root would be positive 2, and my next root would be negative 2. The roots are plus minus 2. There's a positive 2. There's a negative 2. All right. And now I'm thinking I need the vertex again. All right. And the vertex will exist on the axis. And isn't the axis the vertical line right in between these two roots? So wouldn't the axis be x equals 0 right there? Or if you see it as x equals negative b over 2a, you could do it that way too. So let's go up here and go the opposite of b. Well, there's 0 x's up there, so that's going to be a 0. So I get the x equals 0 that way. All right, and now let's find our y coordinate. So p of 0, let's just plug this in right here, and I get a 2 times a 2 is a 4. And that's exactly what I thought it would be. 1, 2, 3, 4. There it is right there. Okay, and that's my y-intercept too. So this parabola is going to go open downwards with roots of plus minus 2 and a vertex of 0, 4. Now, look at the less than or equal to. So the boundary line for this parabola would have to be a solid line. And there it is right there. Now, I'm not going to shade yet because I'm going to graph this inequality right here and then do the double shaded region. Okay, so y is greater than x plus 2. Well, let's graph the boundary line, which is a line with a y-intercept of 2 right there. Okay, and then a slope of 1. So I think I'd use this point right here, because if I go from this point to this point, I am rising 2 and I'm running 2, giving me a slope of 1. So those 2 points right there, here comes my line. And will this line be solid or dash? Well, y is greater than x plus 2, so I need a dash line right there, just like that. Now, where am I going to shade? Because there's lots of regions in this graph, based upon these boundary lines right here. All right, but I have to be less than or equal to 4 minus x squared, so it's below the parabola. Y is greater than x plus 2, that's above the line, so that'd be this region right in here. And there you have it. Isn't that cool? Okay, if your inequality contains just one variable, you must be aware of whether you are working just on the number line or in the whole coordinate plane. So these are really easy, but you've got to be aware of one critical thing. If a question is written like this, find all x such that x is greater than or equal to 3. Do you see any y's anywhere? That tells me we're talking one dimension here. We're talking about a number line. Find all x such that x is greater than or equal to 3. So there's my number line, and the key number on that number line would be a 3. And greater than or equal to, I'm going to have a solid dot. And greater than would be an arrow to the right. There it is. Now, what if this question were written like this? Find all x comma y, which I could say, find all ordered pairs such that x is greater than or equal to 3. Well, there's the y, so I'm in the plane. There it is right there. Now, such that x is greater than or equal to 3, well, think about the vertical line x equals 3 would be right there. And I'm going to make that a solid line because of the equals. There it is, x equals 3. All right, and then x is greater than or equal to that 3, so I'll be talking about everything to the right of that. And there's my graph. So look at the difference of these two. Find all ordered pairs such that x is greater than or equal to 3. My inequality is graphed in the plane. Find all x such that x is greater than or equal to 3. Well, this inequality is graphed on a number line, one variable versus two variables. X is greater than or equal to 3. Beautiful. And your homework, let's do 3.3, 1 through 27 odd. Thank you very much.